Again, hello everyone. My name is Ben Engel, and as Peter already mentioned, I'm one of the technology managers at ASAM who coordinates the OpenX activities, and together with my colleague here, Nico.
Yes. So my name is Nicco Hagedorn. I'm one of the other global technology managers here at ASAM. And today we will give you a short update on what's going on in the OpenX domain. And we also brought a little application example.
Okay, so very quick fly through just what do we mean when we talk about the OpenX domain at ASAM. Just a quick introduction to all of the activities and standards there. We figured because we've got so much ongoing at the moment, it's probably not going to help all of you if we try and give all of you the blow by blow of all of the different activities that are ongoing and how they all fit together and everything, because we've realized that as this domain grows, it's becoming more and more difficult to squeeze this into one presentation. So the format is slightly different in that we won't provide too much background on the current activities. I will try and show you per example how these things fit together and how we envision them fitting together. And on using a brief timeline at the end, we'll try and sort of fill you in on what's going on at the moment with respect to the various development activities in each of these standards and on upcoming standards.
Yeah.
So very quickly, when we talk about the OpenX domain, what we really mean is the simulation domain at ASAM, as it's officially called. We tend to skirt around that term because a lot of these standards are now less just for simulation and are being used for various other use cases outside of just simulation, which is why we tend to talk about it more about OpenX. And that's another reason for why we tend to use open something in front of all of our standards to make clear that they all belong together. So very quickly here on the slide, we have the standards, the activities, or the upcoming standards displayed. And maybe Nico, if you can just walk us through the ones that you coordinate, and then we'll play ping pong as we go through the ones.
Yes, perfect. Yes. I mean, we played ping pong before quite a few times. So so I'm responsible for all the static standards, where static stands for describing the static parts of the environment. So OpenDRIVE is a standard to describe the static road network, letting you describe the semantics of roads. Pretty much not giving any details about how to visualize the road network, but how is the geometry and where are signals and what routes can you take, pretty much. Then we have OpenCRG describing is a binary format, especially used for vehicle dynamic simulation, letting you define a binary format to define elevation values or friction values for road surfaces. And obviously you can combine OpenDRIVE and OpenCRG together. A use case I will show later. Then I will jump to ASAM OpenODD. So Ben will talk about OpenSCENARIO in a bit. OpenODD is still in the concept phase, and we are very close to releasing the concept paper. So that will be released in mid of November. And here we are looking to create a language or a format to have a formal representation of operational design specifications. So they become usable in tool chains and also become interchangeable and comparable. And then we have OpenLABEL, which will be released in its first version also mid in November. And we have the project lead here today, and he will talk a bit about that more in detail, so I don't want to spoil anything.
Okay, great. Then I guess the ball's back in my court. I'll jump to some of the other standards. Again, some of these used to describe some of the more dynamic content in scenarios. Starting, of course, with OpenSCENARIO, for which we have two parallel versions at the moment, OpenSCENARIO 1 and OpenSCENARIO 2. One of them is actually released standard OpenSCENARIO 1, the XML-based format for dynamic content for behavior description, and OpenSCENARIO 2, which is releasing very soon this year that provides a domain-specific language on top of what OpenSCENARIO 1 can do. And these are again used together with OpenDRIVE, so they reference content from OpenDRIVE and OpenCRG, allowing one to have a fully featured description of a scenario, including all dynamic and static content. Moving on, then we have ASAM OSI, the Open Simulation Interface, which is intended as a generic interface between simulation models, whether this is sensor models, which is sort of the legacy topic, legacy in the sense that that was what it was originally designed for, or for other types of simulation models, be it traffic models, participant models, driver models, you name it. The idea being to allow interchangeability between these models and different simulation environments. This generic interface is essentially a messaging format that's based at the moment in its implementation on Google Protobuf messages. And the intent as of now, of course, is that the support for different types of models is going to continue growing. And for now, in the most recent release in 3.3, what we added there was a support for traffic participants. So allowing someone to send messages, maybe commands from an OpenSCENARIO or from any scenario engine to individual traffic participants and back using the Open Simulation interface. So really looking here at harmonizing and adding support for these standards to allow them to be used more effectively with each other. Then we have the OpenX ontology, which is something that will, as we go through today, you'll see that it sort of starts to show itself across all of our activities. This is an attempt to, or this is our way of formalizing the terms, the definitions, the domain concepts in on-road driving, using in some formal representation, in this case an ontology, in order to make sure that all of our standards, once they build on this ontology, speak the same language, that it's easy to map between the different concepts as they are used in these different standards using the ontology. Right, so it goes beyond that, of course, by enabling further workflows because it's an ontology. So it allows things like inference or knowledge-based reasoning based on content. So because it defines terms, relationships amongst these terms, one can use that in a tool chain in order to figure out if the terms are being used in the correct way. For example, in a scenario description. And this is also releasing actually in December of this year, the first version of the ontology. And then we have a sort of a slightly special case in what we have here, the study, the test specification study project, in that it's not a standard or an upcoming standard, but it's actually just a study project. And this has one primary goal, which we'll touch on in the next presentation, actually. So I won't go into too much detail, but it's essentially to provide clarity to the industry on testing for AD, the different types of testing, the interplay between these, and to provide recommendations to the industry, to the standardization organizations on steps to initialize, to improve this interplay between these different techniques, be it between scenario-based testing and other types or any other types of testing, in order to really look at, are there any gaps from a standardization perspective that need to be addressed? And this is a report, again, that's up that I'll go into more depth on in the next presentation after this one. But the idea here, of course, is that the report will also be released in December of this year, with clear recommendations on what to do next. And that is, in a very, very, let's say, small nutshell, the OpenX domain at ASAM. Of course, we have lots more ideas on what we want to do next. And this is all sort of part of the overarching vision that we have for, I'm just going to click through these animations for the sake of brevity, that we have for the different standards and how they're meant to play together. So one core topic that we have, of course, is harmonization. What's very important to us at ASAM is to make sure that these standards don't just work nicely by themselves, but that they also play nicely, particularly with other ASAM standards. And that we want to look at this more as enabling a tool chain that leverages them, or a platform, if you will, rather than usage of just the individual standards by themselves, particularly because so many use cases make use of more than one of these standards. So what we're showing here is just an iteration of previous visions that we've shown in the past, which has sort of shown how our standards could be used together in a test environment. What we're showing here is more just a generalized vision of how the current standards can be used together. And this is what we're using and building on in the background, let's say, in the office, in order to figure out what else needs to be added to this vision to make sure that all of these standards cover different use cases and that they play nicely with each other. So really looking very strongly at this idea of harmonizing the concepts as they're addressed in these standards with one another. And a key player in that, of course, is the ontology, which as of now, is going to map these different concepts because it's difficult to make changes in parallel to all of these standards at the same time. So it's going to provide a mapping between how these concepts are interpreted by the standards. In the long run, it's going to obviously bring us much closer to convergence, so that the terms, as they're understood differently across these different standards, at some point converge to the same meaning. Yeah. So what does Open Simulation Interface understand when it talks about a road, and how does this currently differ to what OpenDRIVE understands when it talks about a road? And this is something that's represented through this mapping and the ontology. And in future, we aim to harmonize this more closely so that these differences or these overlaps are much more clear. Nico, I'm not sure if you want to add any thoughts or comments just on this vision here.
You covered it all.
Oh, that's a shame. Okay. In that case, and again, this is something that we see as very dynamic, and we sort of use it more as a guideline for ourselves internally to figure out where we need to focus or put our current focus on for harmonization activities. So very strongly now, and Nico will touch on it, how to harmonize OpenODD with the ontology, how the Open Simulation Interface, for example, now that it supports sending messages to traffic participants, what else do we need to do to harmonize it more closely with scenario descriptions and more particularly OpenSCENARIO? Right, so really looking here at all of these different interfaces, using, not wanting to confuse it, but using all these different interfaces between these different standards and making sure that we really initiate as many steps where relevant with respect to harmonization. And so now that we've taken that opportunity to very quickly introduce sort of the vision and the domain and the portfolio exactly, maybe now what we'll jump into is this brief demo that it just attempts to show how these standards build on top of each other to enable this sort of full representation of a scenario of the real world, if you will. So then I'll hand over to you, Nico.
Yes.
And
so let me see if I can.
Yeah,
no, I should be able to move the slides forwards. So pretty much when we look at OpenDRIVE, as I said before, is the semantic definition and description of a road network. And I took here a rather simple example, but we can illustrate with that simple examples quite a bit. So when we define an OpenDRIVE road network for that simple T-junction, we can already see that we need quite a few roads for that. So we have 3 incoming roads here, and those are shown using those blue and green arrows. So the blue arrow is the reference line, and then the green arrow is the t-axis. And pretty much that coordinate system is pretty much that way you will put and attach to all the other details of that road network. So the red arrows you can see here are the connecting roads that define the junction. And obviously you need to define all possible ways you're able to drive through the junction. And then you can attach the lanes to those reference lines. And what you can see here are the lane IDs. So 1 and -1 are the lane IDs, and those are pretty much counting up and down in the direction of the t-axis. So once you are in the t-axis in the positive direction, the IDs count up, and in the negative direction they count down. And let's define all of those lanes now for the T-junction. We have the individual road IDs, and we can define for the connecting roads those IDs as well, those lanes as well, so we have something to drive on. And once we have done that, we have that T-junction defined. But we are not done yet because there are quite a few other things we need to define, and these are obviously the objects and the signals. So here we have a static signal telling us it's a speed limit of 50 kilometers an hour. We have a pedestrian crossing, and that will be modeled together with that road mark. We have street lamps, which might play an important role on illumination and the effects on your sensors. And then we have some vegetation, which is always interesting because if you have big trees in autumn, that could make a difference on how the road appears. And we have traffic lights, and the traffic lights would be, traffic lights will be defined in OpenDRIVE, but they won't define the controller. The controller will be only referenced because that would be a dynamic element, and OpenDRIVE does not do dynamic elements. For example, your controller could be defined in any external source, and you could just point to that controller. So your simulation knows where to get that controller. And then we have the zebra crossing as a road mark. Now, what we can see here, those speed bumps you saw before, usually what you would do is use OpenCRG patches, put them on those to have a really good description of that speed bump, so your vehicle dynamics have something good to drive on. And there we already have the first interplay between ASAM OpenDRIVE and ASAM OpenCRG. So yeah, but what else can we do? Because we said before we have ASAM OpenODD and the ASAM OpenX ontology, and they should play a key role in the future as well when it comes to interplay between the standards. So if we take that T-Junction we have here now, we can define or take elements out of the ontology and define a subset. And that is an exercise I would like to show you right now, where we say, okay, let's focus on the road topology because these are the parts we are getting from OpenDRIVE. So the drivable area elements we can see here are obviously the lane elements, the surface type, the edge elements, and the road elements, and the road type. So we have single lanes with a broken lane divider. We have a uniform surface that is tarmac. Then we have grass shoulders. So the green bricks you can see here on the left and right side of the roads suggest that we have a grass shoulder. As we have a sidewalk, if we continue building that Lego model, we would have, so we have a crosswalk, so we will have sidewalks as well. And that thing suggests, as it has a speed limit of 50 kilometers an hour, that we are in a minor road. And so we can add this to our ontology for that piece of road. And we can continue with fixed road structures. So we have street furniture like the speed bumps, the street light. So as we can see here, so we have street lamp of type LED. That could make a difference because usually they use a certain frequency. And we have trees, and here we have small needle trees. So we put all of this together in our ontology. Then we add a junction element to our ontology. Obviously, we have a T-junction here. We can add the special structures like crosswalk. That is important. And we add the traffic signs, the static traffic signs, so the crosswalk, the blue one here, and the traffic lights. They are important as well. And as you can see, these are characteristics that probably match a lot of roads in your city or your environment you need to test in or develop for. And then you can add additional properties like driving direction. Do you have right-hand traffic or left-hand traffic? What lane dimensions are there? Number of lanes, and obviously the primary lane marking color. So, and now we have an ontology that describes the characteristics of that road network. Now, what can we do with that ontology? Obviously, you can go on and on and on, defining more and more characteristics and adding new categories next to road topology. But what we can do now is use that ontology to define our operational design domain. And that operational design domain is usually there to specify the intended domain for a ADS system. And that domain will describe where the car should be capable of operating safely in. And so what we can do is we have two ways of defining that using that ontology, and that is a permissive mode, where we pretty much just include the ODD ontology. And then we say, okay, let's have a permissive definition of our ODD. So pretty much we say permissive, and with that, all our attributes in the ontology are allowed in our ODD. What we definitely have to do, set the non-Boolean attributes like lane dimensions, where we, for example, have between 3 and 5 meters. If the lanes are smaller, maybe that is not defined as suitable for that ADS system. And yeah, so this would be the permissive mode. But usually you won't have an ontology that just covers your domain you want to define. So we definitely have to have the possibility of defining a restrictive ODD or using a restrictive development approach. And here we would include our ontology, same as before, but set the mode to restrictive. And then we can allow what we want, or what would then define that intended design domain where it is safe to operate in. And here we can see how OpenDRIVE and OpenODD and the OpenX ontology, are getting connected, because you can derive all that data from OpenDRIVE that is relevant for your environment. You can match it with OpenX ontology, because they, in the end, in the future, they will speak the same language, as the concepts from OpenDRIVE are already synced with OpenX ontology. And you can use that ontology to define your OpenODD or your ODD itself. And you have something to measure against on how much of that ontology you actually allowed or disallowed in your ODD. Yes. So in the next standard we have that also can be based on an OpenLABEL, on OpenDRIVE, is OpenLABEL, where we can obviously tag all the elements as they are in OpenLABEL, in OpenDRIVE, in OpenLABEL. So if you use your OpenDRIVE file that maybe covers or does not cover your ODD, you can use those objects and tag them and annotate them when you run the simulation in the same way, and you can use OpenLABEL for that. So you have a consistent naming of object throughout the whole tool chain, and I think that will make life a lot easier, especially when it comes from simulation to real-world data. And how would that look like in the end? So let's take that 50 speed limit sign and tag that in OpenLABEL. So OpenLABEL is a schema, a JSON-based standard, and all the annotation data is in JSON. I don't want to spoil too much, because Nico Croce from DeepinAI will talk about that way more in detail. Then we will have an object, a UID. We will call that, give it a name. So the sign speed limit 50. It's a traffic sign. We have object data, and we use a cuboid to annotate that object. And we have the quaternions to define that 3D bounding box we are using here to tag the 50 speed limit sign. Then obviously it is a visible object, so we can see it from the road. Yeah. And now, Ben, back to you.
Great, thanks, Nico. So I'm just trying to, we shifted the slides in advance. Okay, short minute of confusion there, apologies. So now, of course, the next layer on top of all of that is describing all of the dynamic content. And we already mentioned, of course, OpenSCENARIO is designed for this. And we already mentioned that we have two different versions of, or we will soon have two different versions of OpenSCENARIO current out there. And rather than going into too much depth to show how the syntax would look with these different languages, I'll just show a couple of extracts or excerpts from such a scenario description in order to show how we would build something like this using OpenSCENARIO, the two different versions. And I'd rather actually just focus on providing some clarifications on the differences between the versions and what they can and cannot do. So I think all credit goes to Nico for this. We have some cool animations. Nico, I'm not sure if I'm pressing the right button here, so I'm just going to see what happens if I click.
I think I have to start the animations for you, because I'm still in the presenting mode. So there's a button on top that you can take control again.
Okay, interesting. Teams, as we see, all tends to move fast in its developments. I'll let you keep going, Nico, because I have no idea where the right button is.
Okay, so pretty much, let me just run you through what will appear here on the screen. So we have two actors here. So we have that purple truck with the blue door, and that will continue on that, let's call it main road. And we have our ego vehicle, that gray sports car, and we have a pedestrian that will cross the street, and the object is missing. Okay, so that green box contains a pedestrian. Yes, so, and if we move that into action, it should start moving now. And we can see that there she is. Okay, some of the animations broke while we shifted.
The way that we're sharing it here, actually, Nico, via Teams directly rather than sharing the screen is causing trouble.
Yes.
So this requires some imagination, but I'm sure all of you have that. So that in essence, I think it communicates what the intent is. So I'll just jump us onto the next slide in order to very quickly just show the differences between OpenSCENARIO 1 and 2 and provide some background on what these differences actually mean. Now, we have decided at ASAM to adopt 4 levels of scenario, so-called scenario abstraction levels. And these are what we use to differentiate, or these provide one level of differentiation between our 2 different versions, OpenSCENARIO 1 and OpenSCENARIO 2. Essentially, as of right now, OpenSCENARIO 1, the XML-based format, supports very concrete scenario descriptions and logical scenario descriptions, right? And OpenSCENARIO 2 does all of that, as well as also supporting abstract scenarios. None of them support functional scenarios. What exactly does that mean? We have here a graphic that was published in a recent paper stemming from a German research project, a follow-up to some of the Pegasus family of research projects, where they recently revised these levels, which we have now adopted. Right, and again, we have these 4 levels. At the bottom, we have these concrete scenarios, which is essentially one single scenario, so a point in a solution space that describes exactly one specific chain of events or one specific set of scenery with this chain of events. And this is something that is what many of you will have already used, for example, with OpenDRIVE and OpenSCENARIO. As we move up these levels of abstraction, we have logical scenarios, which are essentially a parameterized set of multiple scenarios where various variables or parameters or fields have ranges assigned to them. Right? So we don't just have one speed assigned to an ego vehicle, for example. We could have a range between some upper and lower limit. And this essentially then means it's classified as a logical scenario. And here we have parameter variations, so we have a slightly larger solution space. And we keep going up to abstract scenarios, which are, while still formal, while still machine readable and declarative descriptions, they are much more abstract than the way that parameters are assigned concrete values or ranges for logical or concrete scenarios, right? And because of this more descriptive approach, they use more of a constraint-based mechanism. So effectively saying, keep this value within some set of range, keep it less than, so applying one or more constraints to various values rather than actually defining what those values are. And of course, finally, we have functional scenarios, which are non-formal. Maybe they're natural language-based scenarios. They could be based off of graphics or anything like this. And this is something, of course, because it's not machine readable, with something that is out of scope of the ASAM set of OpenSCENARIO 1 and 2 standards for now. A couple of comments on that, though, right? So we've already said OpenSCENARIO 2 supports abstract, logical, and concrete scenarios. OpenSCENARIO 1 supports logical and concrete scenarios. There is a lot of discussion actually ongoing in the development projects about what actually is a concrete scenario. So when is a scenario concrete enough for it to be defined as concrete, right? Because generally a concrete scenario is understood as being something that I can take as a description and plug it into some simulator that supports the format and instantly simulate. But this has various implications because, of course, it means I need to define a whole lot of things that maybe I don't really care about. Especially when we look at it from an exchange format perspective, to make sure that someone else understands my scenario and that the results are the same as on my simulator, I might need to define things like timings or frequencies and things like this, which is maybe not something that the majority of scenario authors are interested in. So here we're differentiating, of course, between concrete or executable scenarios. Right. And we're sort of taking a more pragmatic approach in this view here, where we're saying a concrete scenario is generally something where everything that I as an author am interested in is defined and everything else is left up to a simulator. And of course, the more I define, the more I guarantee exact replication of performance across different simulators, but obviously the more effort I need to invest. So this is a trade-off, and essentially it's up to the scenario author. So it has to be clear that when we talk about each of these levels, they are also representing a spectrum rather than a discrete level. So a concrete scenario also has a bit of a pretty big range what we consider to be a concrete scenario. Right, and before we jump into what we can do, very quickly again, what we can't do. So these are all very, very basic representations. Nico, you did the sketch, I love it. Very basic representations of what a functional scenario could be, right? And of course, this is something that this is something that we can all understand, but it's not machine readable. So we need to have, and this is why at the moment OpenSCENARIO 2 does not support this. There are use cases that leverage ontologies that approach for more natural language-like descriptions, but these currently are out of scope of the two standards that we're talking about here, and these are sort of looking towards the future. These are sort of potential development points for ASAM or other organizations looking forward. But for now, this is something that the OpenSCENARIO 2 and 1 do not support. As we're slowly running out of time, I just want to very quickly throw on screen, and I'm trying to show a slide, but it seems to be hidden.
Ah, wait. There we go.
There we go. Okay, so again, quick example here. On the left-hand side, we have an out-of-date example. So apologies for this. Teams is obviously not showing the correct version of what we want to show. So I'm just going to very briefly share my screen and hope that that fixes that problem. The disadvantages to trying out new functionality are, of course, it goes wrong when you least expect it to. So apologies, I'm not here in presentation mode at the moment. I very briefly just wanted to show you some of the differences which serve to highlight some of the advantages and disadvantages of the two formats. On the left-hand side, we have OpenSCENARIO 2 and the domain-specific language that we can use to describe small parts of these scenarios at different levels of scenario abstraction. And on the right-hand side, we have an example showing how OpenSCENARIO 1 in its very concrete format, which again, because it's XML, isn't very machine readable, very human readable or very human friendly, is of course quite long-winded. In both all of these versions, so on the left-hand side, concrete, logical, and these abstract descriptions, all of them are doing nothing more than telling some ego vehicle, which has been declared outside of these snippets, to drive at a certain speed. Right. So for our concrete scenario, we're driving at a very explicit speed. For our logical scenario, we're providing some range which we want to drive at. And for our abstract scenario, we're not telling it what speed to drive at. We're just telling it. We're placing a constraint on it and telling it to drive at whatever speed it wants, as long as that speed is less than or equal to 50 kilometers per hour. And on the right-hand side of, again, XML, what we're doing is assigning to the target ego vehicle, we're assigning an absolute speed of 50 kilometers per hour, in this case converted to meters per second, because OpenSCENARIO 1 only supports meters per second. Right, so at a quick glance, you see some of the advantages. There are, of course, disadvantages to these different formats, but we won't have time to touch on that today. To finish off the timeline, and again, we're not going to go through all of this in detail. Some of you might see we're in November at the moment, so we're sort of coming up on a lot of releases. So essentially, where all these arrows end, we have releases coming up. Some of them are releasing middle of November, and some of them, because of some internal shifting, will only be releasing in December. But irrelevant where these arrows end, we have something coming up still to come in this year, and a whole host of new projects planned for beginning of next year. So if you're interested in the outputs of this, stay tuned on the ASAM media channels. And of course, if you're interested in participating, reach out, as well as if, of course, you have any ideas or suggestions for anything that needs to be taken into consideration for follow-up projects. And that, I think, leads us very, very briefly, unfortunately, through the ASAM OpenX standards. I think we might have time for one question before we run out of time and have to jump to the next presentation.
Yes.
But again, if you don't have a chance to reach out to us today, then please feel free to do so per email or offline. We're always available. Thank you. Any questions?
No questions, as I say. Apparently, we explained everything very, very well.
Great. And again, feel free to reach out if you do have anything after the fact. In that case, thank you. And then I guess, Peter,
Thank
I'll
you.
hand over
Back to you. Yeah.